Let's move on with prioritizing technologies for rapid decarbonisation. Electrification, hydrogen, carbon capture, a broad consensus that new decarbonisation techniques are needed. How are they coming along? What is on offer? I'm joined by Gabrielle Walker, who's co-founder of Rethinking Removals and Curate, C-U-R-8. Gabrielle.
Thank you, sir. Can I invite my panelists to come up with me? Okay, you're in for a treat now. We have a really, everyone always says this, right? Moderators always say, I've got the best panel. Well, I really do think I've got the best panel. And they're coming in to sit down now. We're talking about priorities for decarbonisation. We've heard a lot about this, blah, blah, blah. But what we've actually got here today on our panel for you is companies, senior representatives of companies that are right at the leading, or you might say bleeding edge of that. So hard to abate sectors where they're facing what? They're facing high emissions, relatively low margins, not really existing technologies that are at scale that they can use to decarbonize. So a major challenge in terms of how you decarbonize. So we've got representatives of those in this panel. We also have representatives of companies that are ready to provide solutions for scaling new technologies and creating and helping to stimulate innovation in the technologies that we're going to need in the future. And the cool thing is that in some cases, they are actually the same companies. So we're going to hear from them just now. The way that we're going to structure this is, first of all, we're going to talk about the technologies that are already out there, but that need to be scaled. So what we've already got and how we're going to handle that. And then we're going to talk about the innovations, the new technologies, the ones that need to be invented and created. I'm just going to warn you, though, please don't hear now and next in what I'm saying. Because one of the extraordinary things that came out of our earlier conversation, and also that's come out of my many conversations with the companies that I work with, is that it's not now or next. This is the decade of both and. We've run out of time to do these things in series, so we'll be talking about how to do them in parallel. So I'm Gabrielle Walker. I'm co-founder of Rethinking Removals, a non-profit organization focused on carbon removals, and also Curate, a for-profit sister organization trying to look at exactly how we can spread and scale and create the market for carbon removals. And I think we're going to get to that in the second half of our discussion. So without further ado, let me introduce the panelists and let me invite them to speak. So in no particular order, because they're not sitting in this order, we have, well, in fact, slightly this is the right order. We have Antonio Pietri, who's President and CEO of Aspen Tech. We have Emmanuel Cacaras, who is EVP Next Energy Business for Mitsubishi Heavy Industries for EMEA. We have Leslie Harding, who is Global Head of Strategic Relationships, Energy and Transition Risk at Liberty Mutual Insurance. We have Ken West, who is President UOP Honeywell, and we have Scott Parent, who is VP and CTO, Energy and Industrials, ANSYS. They're going to explain to you a little bit more about what they do in this opening question that I have for them. But please tell me, so for each of you, what I want to hear is, with the technologies that already exist, what challenges are you facing in deploying them, and what opportunities do you find in that for solutions?
Well, so in Aspen Technology, historically, and that means the last 40 years, we've been modeling and simulating processes in hydrocarbon industry, both refining oil and gas chemicals. And what we're finding certainly is the opportunity to use those technologies that have been used to model hydrocarbons, the molecules around hydrocarbons. Some of those molecules are also being modeled for renewables, and then also the electrons around global electrification. Just to get to your question, the challenge that we see at the moment is one of understanding the return on investment for these new capabilities around renewables, but also then how these technologies are applied in these new use cases around biofuels, around hydrogen, around CCS, or direct air carbon capture, and bringing the capacity and the capabilities to our customers to use these technologies in those cases. So it's a matter of scaling knowledge, understanding the return on investment for these technologies, and then applying them in the market.
Sure, thank you. So, Scott?
Sure. So ANSYS is a simulations company and has been around for about 50 years, similar but complementary to what you heard from Anton, at the component systems and complexity of physics. So everything from aerospace to medical to the energy and industrial sectors. And so ANSYS has spent a lot of time in the last 50 years working particularly well with companies in the automotive and aerospace and space arenas on reducing risk and time to market on everything that is related to safety, performance, and efficiency. And I would suggest probably one of the biggest challenges, having been myself in the oil and gas and energy space for now about 30 years with GE, BP, and Baker Hughes as a technology leader, is this adoption of we're going to simulate first. We're not going to build and break. We're not going to test and tweak. We're not going to take decades to learn things in physics that we already understand and know quite well and can demonstrate that we can use both in aerospace, space, automotive, and medical, and have been used radically in the last few decades with the help of high-performance computing and some of the other technologies to advance this idea that design and risk in design can be managed much better. And at the large scale that we have in oil and gas and energy and the risks that we take in this space, this is the time really culturally and by training and upskilling the engineers in this space to take a much more simulation-first approach. And I think this is going to advance our space even faster in the low-carbon solution space.
So simulation first, that, in a way, that's a bit more about new technologies than it is about existing ones, right?
Well, it is. Well, no, not really, because if you think about it, even today, I'll take something as simple as a water pump. Water pumps are responsible for about 10% of the usage of power, electricity on planet. And we have a customer, Denmark, Grundfos, great company, #1 in the water pump space, who in the turn of 2 product innovations, so 8 to 10 years, have improved their performance by 80% on efficiency. 80% on efficiency. So we think of that, 10% electricity goes to water pumps. The same thing with motors, right? Motors are 45% of the electricity use on planet. That's basically 50% of the greenhouse gas emissions from electricity and generation of electricity. We've seen the same sorts of improvements. And before the whole world moves to electric cars, wouldn't it be nice to make those efficient and much more efficient in terms of the use of energy? So I think on current technologies, we have the opportunity to knock out and improve emissions immediately, really in the first turn of the dial, using these digital capabilities, and then certainly on new carbon solutions to advance and speed their maturity and scaling.
Sure. So I just want that to sink in for a moment, because that was 80% improvement in efficiency. Right. And that's something that was already lying around, right?
That's something that's already lying around, and it's looking at components, systems, and subsystems of those systems and doing an optimization. I mean, we were having this conversation just before this, and I won't take up too much time, but when we build a power plant today and there's 8 different OEMs, somebody delivering the turbine, someone's delivering the heat exchange, there's margin in every piece that is put in that system. If somebody does not do a systems optimization of that, we're leaving that margin on the table, which is cost and in terms of efficiency, really a problem at the scale in which we work at in oil and gas.
Sure. So I think we're going to come back to that point about systems thinking in a little while. I'm just going to skip for a moment, Leslie, to go straight to Emmanuel, because sticking to existing technologies, so Mitsubishi, you already told me that you think that the technologies are out there. It's all about scaling, right?
Yep. So I'm coming from Mitsubishi Heavy Industries. We are a technology company. We are putting in place technologies that are based on scientific knowledge, on years-long R&D. We have a very powerful research and development program. And we are committed to decarbonization, because our credo the last 140 years is delivering technology solutions with social responsibility. So in that context, we have responded to a very ambitious decarbonization strategy, which brings different technologies from different disciplines around our portfolio, addressing both existing assets and new assets. And this scale-up ambition, which can extend from carbon capture to hydrogen, to electrolysis, to hydrogen storage, to hydrogen back to power, to name a few energy-related examples, but it extends also to infrastructure projects, to logistics, and so on. All this come with a considerable upscaling effort, and this upscaling effort is achieved by means of the technology tools that these two gentlemen are putting in place for the last decades, and we are very glad to use. So we combine scientific expertise, lots of thorough testing. Every product that comes out from Mitsubishi Heavy Industries has a 2 years testing period under real full-scale conditions and thousands of hours of computational simulations. And in that context, I think we are ready now for the next step towards decarbonization, which is the upscaling and delivering carbon-free energy infrastructure at scale, reliability, and at cost competitiveness, which is a factor that we cannot neglect now.
So this is existing technologies, the challenge now is to scale them. What will it take?
Yep, I think if we take the commitments towards carbon neutrality for 2050, you cannot have the time to invent the new technologies. So we have to rely on what we have in hand, and this is enough. All simulations demonstrate that we can achieve decarbonization by using, for instance, carbon capture for the hard-to-abate sectors, and this is an existing technology. We can rely still on electrolysis to produce hydrogen at scale, and this is an existing technology known for 200 years. The difference now is in the business model, is on the scale, on the efficiency, because we have to be efficient in using resources in the most productive way. So I'm not worried about, although I'm coming from R&D and I've spent 25 years doing R&D, but I'm not worried about the new knowledge. What I'm worried is how quick we can do it at scale and at the pace needed to achieve our targets.
Exactly. So what do you think? How are we doing on the existing technologies? Do you think we've got enough? And what will it take to scale them? Leslie?
Yeah, no, very similarly, at Honeywell UOP, we have a very unique position with over 100 years of experience in the design, engineering, and licensing of technologies for many of our energy partners. We've been able to couple many of these technologies that exist today. Just as you said, it's not necessarily new or new inventions or new technologies. It's existing technologies and partnering and collaborating in a way to use these in an efficient manner to drive carbon capture, utilization, and storage. Or even, I mean, a great example is our sustainable airline fuel, where we've signed over 45 licenses globally. This is happening today. This isn't something that is years out into the future. So I really do feel there's a big piece of the energy transition that is going to occur from existing technology and technology from our existing customers. Another great example is the whole push to electrification. To meet the goals of many of our customers, it's going to require some level of electrification, and Honeywell is also supporting that in terms of being the enabler for new heat pumps, and heat pumps that are used in new manners, being able to move away from some of the traditional heating sources into new, more energy efficient heating sources. As we take a look at the energy transition today, it's going to be a question of not or, but and. It's going to take the complementary use of these technologies and partnering those and collaborating with many of the folks that are right here on the stage to come up with new and unique applications, but not necessarily inventions.
Brilliant, thank you. So, Leslie, what you're going to tell us about risk and financing that risk. What risks are there in scaling these technologies that these gentlemen have assured us are perfectly in there, sensible, natural? They're already there. We don't need to worry about it too much. We can just scale them.
Looking at this from two perspectives, I'm absolutely in favour of it. It's the and, not the or. And so for years we've been actually ensuring a lot of the technologies which are now being deployed at scale very successfully. What's slightly different, just picking up on the comment from Emmanuel, is we have some new business models, and that we need to take into account because we've got some new partners coming into play, which creates a different type of risk. But we've also got, within the insurance sector, deep risk engineering capabilities. And what I'm hearing from the panel is that we've got now risk mitigation techniques that are not yet being adopted and understood by the insurance sector. So when it comes to the question of, how do we get these projects to scale, they need financing, and the insurance sector actually is the enabler to that financing, but a deeper relationship and a deeper collaboration with the tech players will allow us actually to get more efficiency into that model, and that's absolutely key, because there's only a certain amount of insurance capacity. Let's not waste it by actually insuring technologies which are inefficient. Let's actually use it on technologies after we've actually created those efficiencies.
I'm quite surprised. I'm hearing this word efficiency more or less from everybody. And you don't typically hear people saying the way to scale is to get more efficient. You think getting more efficient is about, sort of saving money or not wasting resources. But really, as a driving force to scale?
Well, I mean, triple renewables and double efficiency, and efficiencies is a low-hanging fruit, and it will continue to be. Of course, the sexy, the shiny objects are talking about scaling hydrogen or scaling CCS, but the fact is that there's a lot of CO2 emissions reductions that can be achieved from driving greater efficiencies in operations, and these are technologies that have been around for 20, 30, 40 years, and that have been implemented at scale. So there's a very strong focus on efficiencies, but also then in parallel, you have to scale new solutions. And when it comes to risk analysis, part of the scaling is understanding the risk that you're taking on when you're trying to build a hydrogen plant at scale or a CCS facility. So we see our customers actually very keen on doing system analysis, risk analysis, reliability analysis around new assets that they don't understand yet from an operation standpoint, and therefore, it's new assets in a supply chain of many other assets. So part of what they're taking on is okay, how is this going to fit in my overall portfolio of risk and profitability? And in that, we'll continue to focus on efficiencies.
That's an interesting point, because if a technology already exists, that doesn't mean that we understand well what it's going to be like at scale and what liabilities might be associated with it at scale, right?
Right, and increasingly, if you think about renewables, right, those technologies are sitting in a very volatile, i.e. nature, that is from a predictability standpoint at best 7 days out in terms of what we think is going to happen in both, whether it's a solar farm based upon cloud cover or offshore wind based upon hydrology, currents, and hurricanes. So those volatilities make that challenging, and of course, risk reduction becomes the idea of understanding what that predictable condition might be, and the faster the better. But I would say, look, maybe just the last comment I'd make on efficiency, adding to what Antonio said, is 65% of the energy on planet produced, converted, and consumed is wasted. 65%. So, we believe that with existing technologies, as Ken was discussing, and Emmanuel, both at those companies, those existing technologies can help take that number down, we think, by 40% in a very, very short order, with a lot of predictability, because we understand how these products perform today.
Yeah, Leslie?
Can I just pick up on Scott's point? Because I think one of the key issues here is also to build in resilience into the projects as they're being developed. And one of the key areas I think that's really ripe for exploration is bringing in the data and the insights and the analytics around climate risk modeling and resilience into the design phase. And I'm not sure that we're quite there yet with that.
Sure. Scott?
Yeah, you know what they tell, the greenest kilowatt hour is the one not spent. So that means that we have to do our homework first and exploit every possible potential for energy efficiency, having in mind that we have a paradigm shift, that, for instance, the overproduction of electricity from renewables turns the thermodynamics a little bit upside down. Now, electricity is a primary energy, not a product of energy conversion. But I like the comment of Ken about the heat pumps. Heat pumps is an excellent example how you remodel a product known for decades from an application A, which was kind of domestic heating purposes and air conditioning, to application B, which is large-scale industrial application delivering the carbon reductions at scale. And that means I might have sounded a little bit too conservative when saying that the technology is already there. Technologies are, I think, inventions are already there, but the use, it takes lots of engineering and lots of effort and ingenuity to convert this technology towards the new target. And I think we are all of us are talking about, ambitious targets, taking CO2 from the air, taking CO2 from the hard-to-abate sectors. But we, in developing countries where energy poverty is a reality, I think the energy efficiency is the first contribution that industrial and technology providers can deliver to bridge the gap and deliver decarbonization.
I'm going to come back to that in a moment, but sorry, go ahead.
Well, I think maybe to add on to that, I think it's absolutely right that the equation starts with efficiency. And when you think about the conversations we're having with our customers, they're coming to us with a problem statement. And how are they going to meet their ESG goals? How are they going to reduce their emissions? And I like the example on what is the greenest kilowatt hour, because if you start with the first step of measuring and monitoring, and we have a number of technologies within Honeywell, as many other companies do, that can go in and lay that out and at least define where you are, then that gives you a great opportunity to go in and target what is the most efficient way to meet your energy goals. And that's really where, I believe at Honeywell UOP, we've started to partner with our customers. It isn't one technology, it isn't two technologies. Many times it's looking across whether you're in the energy sector or a hard-to-abate industry. It's looking across that industry and saying, how can we best partner with you and how can we help you with the right technology to meet your goals in the most efficient way?
So that's yet another example of why it's important to be able to see the big picture and the interconnections. And what I think is interesting about this, as I started off saying, it's a challenge in the hard-to-abate sector because you have low margins, you have high emissions, you don't have existing scale technologies. What I'm hearing here is that, yes, it's a challenge, but targeting efficiencies in the approaches can actually be something that you don't have to try and persuade a CFO is going to be important for your business. It's already got a benefit right there in terms of who pays. So I wanted to move on now if I can, because I've heard various suggestions, comments about technologies that are really well established, like solar and wind, that I remember very well when they were kind of just very, very nascent and seemed very strange and different, and now they're absolutely mainstream. And I've also heard mention technologies like carbon capture and storage, point source carbon capture and storage, where, yes, it's an existing technology that's been around for a long time, but it hasn't scaled. And is now starting to scale, so starting to experience those difficulties. And now let's move on to the technologies that are really, really nascent, that haven't been around at all, and that will need to scale in parallel at the same time. And I've heard a few people mention taking carbon from the air, direct air capture. It's the thing that I'm working on now 24/7. And the reason that I switched, I've been working on climate change now for 30 years, God help me, and I switched to carbon removals about 5 or 6 years ago because I saw the size of the hole. And we know a lot about how to get emission reductions, and are working quite hard on that, but really haven't paid very much attention how to get emissions removals, taking the carbon dioxide back out of the air and keeping it out. So those are very nascent technologies with different risk profiles. We know almost nothing about them. We have technology risk. So give me some thoughts about that. What about these new nascent technologies, and how do we handle those?
Well, let me start because the fact is that our solutions are being used by some of these early innovators in the direct air carbon capture system, companies like Carbon Engineering, Carbon Capture, and others. And Occidental is a customer of Aspen Technology, so it's Carbon Engineering. So they're building the largest direct air carbon capture plant in the world. And this is back to system analysis, risk analysis, reliability analysis, because these are new assets that were the operations, the reliability of that equipment is not well understood. So a lot of time is spent in trying to understand the technologies. We have a customer called Carbio. They do enzymes for the recycling of polymers. The enzymes process the polymers and break it down into its original monomers, and they're targeting that technology for plastic circularity. So there's incredible innovation going on at the moment. And the interesting thing is that solutions and technologies that have been around to model and simulate and operate hydrocarbon facilities are the same technologies that are being deployed in these very innovative use cases for sustainability. And therefore, there's an acceleration on the use of that technology. So we're very optimistic. Over the last few years, AspenTech now has a new generation of customers, I call them, that are all about sustainability, but they're using the same products and solutions that we've always had.
Sure.
Yeah, I'd add to what Anton just said, just briefly, in that when we look at some of our biggest customers in the energy space, it's not the traditional oil and gas customers that we would have thought of tomorrow. It's exactly as Anton suggested. We have two of our biggest energy customers, fastest growing customers. One is in the small modular reactor space, and the other is in the fusion space. And so these folks are taking a very, very analytical, very, very, if you would, simulation first approach, because they want to look at the uncertainty. And there's a lot of uncertainty. And I don't think anybody in the room, unless you're a really bad husband, steps on the gas when you're lost, right? You pull over, right? And there's probably almost nobody here, whoever's driven in traffic, that doesn't pull up Google first. That's a simulation.
Right.
And yet we find in this industry, many folks are still stuck in the paradigm, and it's certainly not the OEMs to the left of me. These folks have deep science and engineering, and what we used to call over-engineered is actually over-engineered for material usage and all of these things that you want to reduce when you build a complex system. But ultimately, this idea that I can understand where I'm going better, faster, I can approach the problem. And again, the Google Maps is maybe overused, but it's actually a very, very simple way of looking at how we would say in these new technologies that are going to play in many different applications in different ways and integrated systems, we want to iterate on those things we don't understand. And that gives us a chance to build a much larger control volume around the problem we're trying to solve, and then recognize where we are missing data, we have to collaborate or go get that to make our solutions better.
Sure. So in that context then, what about the risks associated? One of the things that has become abundantly clear in my work is that, we all know this in the green tech space, first-of-a-kind projects are really hard to finance, especially when there's technology risk, and especially when there's no credit history. And why would there be a credit history if you're inventing something essentially from scratch, but you have to do it really fast? So how can insurance help with the financing of that?
So we recognised this issue about a year and a half ago, and we partnered with MIT as part of their energy initiative to really get access to these guys who are developing new technologies and to understand what the process was that they were going through. And it gives us and our risk engineers and our risk control folks really much deeper insights into the evolution of a technology, from the germ of an idea, two men in a garage, to something that's pilot and then pre-FID, and then hopefully they get the financing to be able to go off and have a demonstrator project. And it's that next phase that's going to be obviously very critical. But it's understanding where that project has come from. In addition to that, we're part of a group called the Geneva Association, and it's basically 80 Geneva Association. 80 insurance and reinsurance companies who've come together. They've taken the technology readiness level frameworks of the industry. They've taken the adoption readiness level frameworks for emerging green technology from the DOE. And we're actually working towards insurability readiness frameworks now. And we're doing that in partnership with companies like Breakthrough Energy and with other university groups. And we're also doing it with other financial investors as well, which is really helpful because it brings together that entire community. So it's not just the risk finance teams, it's actually the end finance carriers. And also, it does allow you to have that, because you've got this umbrella organisation, it allows you to have this collaboration to really understand. We've identified 20 risks that are actually really key and critical, of which we're now looking at which of those 20 risks are actually insurable, and then going back to that community and saying, well, how do we make those that are not currently insurable, insurable? And partly it will be actually reaching into the data, the simulation technologies that these guys are addressing, and that really deep kind of risk understanding, which will allow the commercial insurability of some of those. So it's a fascinating project. Yeah. Due to launch the first one on green hydrogen in February, the first report.
Right. and hopefully there'll be more of those task forces
There
coming.
will be more following.
I would love to see one on carbon removals. I put it in here now. Let's see whether you'll do one. So just thinking about how to get finance to these kind of first-of-a-kind projects and how to get finance to scaling. Risk is obviously sort of front and center of all of this, and insurance is one part of dealing with that. Are there any other ways of dealing with it? What's the way to get money there?
Yeah, maybe I can add there. I think the number one key to getting financing for these projects is making sure that they're economically viable. You know, institutions are out there in the business of financing, and they want to finance projects that have good paybacks and that have strong returns. And the way to get that is to help drive the demand for these technologies and drive the demand for these solutions. You know, you see that already. I talked a little bit about how successful we've been in sustainable airline fuel, or SAF. And that's come because of regional mandates that are helping drive the demand for those fuels, that are helping drive the industry to build the infrastructure around it at returns that are viable. As we look at the other technologies, again, what I think I've heard from all of my colleagues on this panel is many of these technologies are there today. They're not necessarily new technologies, but we have to scale them in a way that's economically viable and reduces the risk for those that are going to put the money up for them.
That's super interesting, and I think what's interesting there is that it's not just sort of sitting back passively and saying, is it economically viable in the current situation or is it not? Lots of these are kind of market-making plays. I know that in our work on carbon removals, talking to global banks about how to get the money to the projects when they're first of a kind, the banks have told me that offsets, offtakes, long-term offtakes from companies, demand signals are the beginning, the middle, and the end of getting the money there. So it's actually something where companies can step up and promise to buy in order to create the industry that they're going to need, right?
Yeah. And look, companies like Liberty Mutual, they want assurance that if they're going to finance a project, they're going to get their return. And this is a new, the Sadara petrochemical complex, the largest petrochemical greenfield project ever built, $20 billion projects. Liberty Mutual, I learned, was one of the companies providing the financing, but the design team came to us and really driven by the banks because they wanted assurances that that design was going to deliver the production rates to meet the financing covenants. We are seeing that around hydrogen and carbon capture and sequestration. It's not new, it's just that everyone wants to ensure that the return on investment is going to be there, the economic model makes sense, and therefore they go and use the same technologies that have existed to provide that assurance in traditional industries.
Sure. Thanks, Emmanuel.
Yep, I think the key answer to the first-of-kind projects question, which is a pivotal element to achieve these sustainability goals, is the partnership. Mentioned already before, we have to go hand in hand, we as a technology supplier with a partner who needs the product and commits to the product. And then what is a first of kind? A first of kind is a project that does not rely on references, on commercial references. So there is an increased risk. And we, as a technology provider, we help de-risk the project by taking an active participation from the early stage. So we grow as a technology provider with the product, with the project, and this has been already proven in examples both in the US, the project we are doing in ACES in Utah, the biggest hydrogen back-to-power project, the projects we are doing on green steel in Europe together with our steel partners there. All of them are an early engagement that allows us to know also the financial parameters of the project early enough. Having the technology provider in the project team gives more comfort to the financing organization, to the insurers, and then we create the market and the industrial references that are needed so that the market will take over, and then we'll have a next generation of mature projects that can be realized in pure market terms. And because that's the de-risking activity, it justifies some public funding, and we demonstrate in that way that the public money spent in this type of first-of-kind project is money well spent because it tops up commitments for both ends, the end user and the technology supplier.
Really, it's a super point. So I just want to emphasize that there. The idea that who's actually involved from the beginning can give a lot of comfort to the banks. So, you know, the long-term offtake, if it's from someone who's has a very good credit history, if somebody's involved from the beginning who has a very good record of delivering technologies, that's going to give comfort. I'm going to stray off this topic now just briefly because we're almost at the end of our time. I told you you're in for a treat, and it's been a very rich conversation. But what I want to do is I just want to remind us, because there's been a very positive, kind of forward-leaning aspect to this group. It's like, this is how we scale, this is what the solutions are, we know what to go after, this is what we're bringing, and that's why it's my kind of panel, because I'm a positive, forward-leaning kind of person. But it has to be said, we are not going fast enough. We are not going fast enough. Things are going backwards. And that's one of the things that we're encountering here at COP28. The global stocktake is showing us that we're not going fast enough. So just in a couple of minutes each, if I could ask you, you each, starting with you, Emmanuel, just what will it take to accelerate this, to bring a sense of urgency to this, rather than just a kind of sitting back and saying, that would be nice if somebody did something?
Risk-sharing appetite, maybe.
Say again?
Risk-sharing appetite.
Risk-sharing appetite.
I think this COP is about deployment and delivery. It's not, the targets have been set, the tool set is there, so we have to deliver. And to deliver, we cannot deliver alone. We need partnerships which share the same vision. We need policymakers that are embarking on this trip. And I think we have all elements to speed up.
Brilliant, thank you.
It's partnership and collaboration. There isn't going to be time for every company to invent every aspect that's needed. It's going to take new partnerships, new collaborations with a new set of customers.
Do you think there's the appetite for that out there?
I do. I've actually, in the last 12 to 24 months, I've probably seen much more openness to thinking about how do we work together to solve the problem versus how do we compete against each other on the same problem.
Brilliant, thank you, Leslie.
Yeah, I would kind of echo that. I mean, I come from an oil and gas background where there's always been a lot of collaboration and there's been joint venture partnerships. And what I would say is we actually need frameworks for collaboration. This has been great because it's allowed us all to have a little bit of an insight into the problems that we're each facing. We need frameworks that will allow us to bring the policymakers, the financiers, the technologists, and the developers actually together at an early stage before anything is actually created.
Great, thanks.
Yeah, look, I think we all understand the why. That's why we're here, about decarbonization on the planet, and I think most folks are grounded there. The what is still being evolved. There's a number of different technologies that exist today on different time horizons, on growth and scale of the energy systems on planet. We probably have new technologies that need to come in before the end of the century or mid-through century to make that plausible. The how is, I think, something Antonio and I are talking about. We know the how. I use the example, you don't step on the accelerator when you're lost. If you do, you're like my dad. You use the tools that are available today, and we've demonstrated that these tools and other industries can explicitly eliminate most safety concerns in spaces that include DART missions and launching to the moon and insert anything you want there in terms of concern of risk. And I think we have to change the culture here. This is not an opportunity to say what we've done in the past is wrong, but empirically we understand a lot of the physics and technology that we've applied in the past, and we need to learn from that and make that a way to go faster.
Brilliant, thanks. Antonio?
Yeah, I mean, similar theme. I love the heading, triple renewables, double efficiencies. Is the double efficiencies piece is a low-hanging fruit. There's not enough focus on efficiencies. The 40% reduction in emissions by 2030 will be achieved mostly through efficiency gains. Has to be, because it is the time that it will take us to also scale hydrogen CCS, which is a sort of 2030, 2040
what gives
technology.
Urgency to that? What gives urgency?
What gives urgency? Well, the fact that we're not on track to do 1.5 degrees by 2050 at the current trajectory, if that's a goal. And the other thing, and Ken said it, and it's been mentioned, is partnerships and collaboration. Absolutely, over the last 2-3 years, customers have shifted to partnering and collaborating with key suppliers, because this is a very hard energy transition in the time frame that we've given to it, and therefore everyone is looking for help to achieve this transition.
Brilliant, thank you. So what I've heard in this panel, very briefly as a summing up, so there's a lot of technologies that are already out there that need to be scaled more rapidly. There's risks associated with that, but there's also opportunities for handling those risks. There's new technologies to come. I've heard a lot about, and similarly, there's risk, but there's ways to get the money there, and the ways to get the money there can be involving reputable players from the beginning to give comfort to the banks, having insurance, looking at other ways of financing first of a kind, and risk sharing. I've also heard about efficiency in lots of different ways. The use of efficiency and simulations that can provide an understanding of where the efficiency might be. There can actually be a massive quick wins in the sense of urgency, but also efficiencies in business models, efficiencies in approaches, so that actually looking for that as a way to give impetus and energy to the scaling. And I've heard that, above all, we're going to look at the how and not just the what and the why. And I'm frankly tired of hearing the what and the why. We all know what the why is. We all know what the what is. And what I've been hearing today really is practical how. And to focus on the how, the way to do that is going to be through the collaborations that are already starting to happen. Because more and more players are realizing that if they stay in a competitive mindset, they're not actually going to achieve this. You know what they say is, they say to go fast, go alone, to go far, go together. I would like to say to go fast right now, go together. Thanks very much to our panelists, and thanks for having us.